The National Electrical Code, or NEC, does not permit locking circuit breakers in the on position. The NEC mandates that circuit breakers have a provision for locking them in the open position, as outlined in NEC section 240.83. This requirement is rooted in safety concerns and is intended to ensure that electrical circuits can be de-energized for maintenance, repairs, or in emergency situations. Locking a circuit breaker in the on position would defeat the purpose of the breaker, which is to automatically trip and interrupt the circuit in the event of an overload, short circuit, or ground fault. Firstly, the primary function of a circuit breaker is to protect electrical circuits and equipment from damage due to overcurrent conditions. When the current exceeds the breaker's rating, it is designed to trip, effectively cutting off the power supply. If a breaker is locked in the on position, it cannot perform this protective function, which can lead to overheating, fires, and equipment failure. Secondly, the NEC provides specific guidelines for the installation and use of circuit breakers to ensure electrical safety. These guidelines cover various aspects, including breaker ratings, overcurrent protection, and lockout/tagout procedures. Locking a breaker in the on position would violate these guidelines and create a hazardous situation for personnel working on or near the electrical equipment. Thirdly, lockout/tagout procedures are essential for preventing accidental energization of electrical circuits during maintenance or repair work. These procedures involve de-energizing the circuit, locking the breaker in the open position, and attaching a tag to indicate that the circuit is being worked on. Locking a breaker in the on position would render these procedures ineffective and could result in serious injury or death to personnel. The statement that a circuit breaker can be locked in the on position as long as it has an internal trip is incorrect. While some breakers may have internal trip mechanisms that are designed to trip the breaker under certain fault conditions, this does not override the requirement for the breaker to be able to be locked in the open position. The ability to lock a breaker in the open position is a separate safety feature that is intended to prevent accidental energization during maintenance or repair. The internal trip mechanism is designed to protect the circuit from overcurrent conditions, while the lockout/tagout feature is designed to protect personnel from electrical hazards. These are two distinct safety features that should not be confused. It is essential to adhere to the NEC guidelines and always ensure that circuit breakers can be locked in the open position for safety purposes. Violating these guidelines can have serious consequences, including property damage, injury, and even death. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical safety. Circuit breakers serve as vital safety devices in electrical systems, safeguarding against overloads and short circuits. Their primary function is to interrupt the flow of electricity when a fault condition arises, preventing damage to equipment and reducing the risk of electrical fires. The NEC mandates that circuit breakers must be readily accessible and capable of being locked in the open position. This requirement ensures that electrical circuits can be safely de-energized during maintenance, repairs, or in emergency situations. Locking a circuit breaker in the open position is a fundamental safety practice that prevents accidental energization of the circuit while work is being performed. This practice is often referred to as lockout/tagout, and it involves physically securing the circuit breaker in the off position using a locking device and attaching a tag to indicate that the circuit is being worked on. The NEC provides detailed guidelines for lockout/tagout procedures to ensure that they are implemented effectively. These guidelines cover various aspects, including the selection of appropriate locking devices, the identification of authorized personnel, and the documentation of lockout/tagout procedures. In addition to the NEC requirements, many companies and organizations have their own internal safety procedures that further emphasize the importance of lockout/tagout. These procedures may include additional training requirements, specific lockout/tagout forms, and regular audits to ensure compliance. It is essential for all personnel who work on or near electrical equipment to be thoroughly trained in lockout/tagout procedures and to strictly adhere to these procedures at all times. Failure to do so can have serious consequences, including electrical shock, burns, and even death. The NEC also addresses the issue of arc flash hazards, which are another significant safety concern in electrical systems. Arc flash is a dangerous phenomenon that can occur when a high-voltage electrical discharge jumps across a gap between conductors or between a conductor and ground. The resulting arc can produce intense heat, bright light, and a pressure wave that can cause severe injuries or even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings to alert personnel to the potential danger. These warnings typically include information about the incident energy level, the working distance, and the required personal protective equipment, or PPE. Personnel working on or near electrical equipment must wear appropriate PPE to protect themselves from arc flash hazards. This PPE may include flame-resistant clothing, safety glasses, gloves, and a face shield or arc flash suit. In addition to PPE, the NEC also requires that electrical systems be designed and installed in a manner that minimizes the risk of arc flash. This may involve using arc-resistant equipment, installing overcurrent protection devices, and implementing grounding and bonding systems. The NEC is a comprehensive set of standards that provides detailed guidelines for the safe installation and operation of electrical systems. It is essential for all electrical professionals to be familiar with the NEC and to adhere to its requirements at all times. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important to stay current with the latest edition of the NEC to ensure that you are following the most up-to-date safety guidelines. In addition to the NEC, there are other codes and standards that may be relevant to electrical safety, depending on the specific application. These may include local building codes, fire codes, and industry-specific standards. It is essential to be aware of all applicable codes and standards and to comply with their requirements. Electrical safety is a shared responsibility, and it is essential for all personnel who work on or near electrical equipment to be proactive in identifying and mitigating potential hazards. By following the NEC guidelines, implementing lockout/tagout procedures, and wearing appropriate PPE, we can create a safer work environment for everyone. The NEC provides tables for ampacity. For example, Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in raceway, cable, or earth, based on ambient temperature of 30 degrees Celsius. Other NEC tables include conduit fill, box fill, and grounding conductor sizing. Overcurrent protection is critical in electrical systems. NEC Article 240 covers overcurrent protection. Section 240.4 covers protection of conductors. Conductors must be protected at their ampacity. However, there are exceptions. For example, 240.4b allows for the next standard overcurrent device rating if the conductor ampacity does not correspond to a standard breaker size. However, there are limitations based on conductor size. Small conductors, such as 14 AWG, 12 AWG, and 10 AWG, have specific overcurrent protection limits, typically 15 amps, 20 amps, and 30 amps respectively. Branch circuits are covered in NEC Article 210. A branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet. Branch circuits are classified by their maximum overcurrent protection. For example, a 15 amp branch circuit is protected by a 15 amp circuit breaker. A 20 amp branch circuit is protected by a 20 amp circuit breaker. The NEC provides requirements for the types of outlets and loads that can be connected to different branch circuit sizes. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which allows the overcurrent device to trip and clear the fault. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of electric shock. NEC Article 250 covers grounding and bonding requirements. The size of the grounding conductor is based on the size of the ungrounded conductors. Bonding conductors are sized according to NEC Table 250.102. Electrical panels must be properly labeled to identify the circuits they serve. This helps to ensure that the correct circuit is de-energized during maintenance or repairs. Panel schedules should be up to date and accurate. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes proper wire terminations, secure connections, and proper support of cables and conduits. Electrical installations should be free from defects that could create a safety hazard. Electrical inspections are an important part of the electrical safety process. Electrical inspectors review electrical installations to ensure that they comply with the NEC and other applicable codes and standards. Electrical inspections help to identify potential hazards and prevent electrical fires and injuries. Always contact a qualified electrician for electrical work. A qualified electrician has the training, experience, and knowledge to perform electrical work safely and correctly. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. The NEC is not law unless adopted by a local jurisdiction. States, counties, or cities typically adopt the NEC as their electrical code. It is important to check with your local building department to determine which edition of the NEC is in effect in your area. Continuing education is essential for electrical professionals. Electrical technology is constantly evolving, and it is important to stay up to date on the latest advancements in safety practices. Continuing education courses can help electrical professionals to maintain their skills and knowledge and to provide safe and reliable electrical services. The goal is electrical safety. Electrical safety depends on following best practices and complying with the NEC. All of this should be followed to minimize electrical hazards.